Lesson 19.1, Task 1. Quadratic functions in vertex form. Identify characteristics of the parent quadratic function f of x equals x squared. All right, so remember the parent function is the basic form of that function. So for quadratic, y equals x squared, or f of x is function notation. F of x equals x squared is your parent function. So it's the most basic function for a quadratic equation. A function that can be written in the form f of x equals ax squared plus bx plus c is called a quadratic function. The most basic quadratic function is the parent function f of x equals x squared. Complete the table for f of x equals x squared. Do not repeat any x value. Graph the function using the data from the table. All right, so all we're doing is simply plugging in values to see what it equals. So if I take -4 and I square it, -4 squared is 16. Remember, any number squared is positive. -3 squared is 9. All right, so if I have 4, what did I square? -4, -3, so this would be -2. You know, 2 squared is also 4. But we're looking at the table and filling in the blanks. So we know that this one should be a -2, and you square -2 and get 4. So if I take -1 and square -1, I get 1. And then if I put 0 in and I square it, I get 0. And then I take 1 and I square it and I get 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So you can see how that these go from -4 down to up to 0 and then on up to 4. So these are increasing by 1. And you can see that these go down to 0 and then back up. So that's why we get that U-shaped graph called a parabola. So that's our table. And it says, recall that the graph of a quadratic function is called a parabola. The highest or lowest point on the parabola is the vertex. So for this function here, this is the points that we just made in the table. 0, 0 is your vertex. That's the lowest point on this quadratic function. All right, complete the statements about the shape and vertex of the graph of f of x equals x squared. The graph is a parabola. The graph is shaped like the letter U. Remember, a V-shaped graph is absolute value. Quadratic equations are a U-shape. The vertex of the graph is located at the lowest point here, which is 0, 0. All right, an axis of symmetry is a line that divides a graph into two congruent halves that are mirror images of each other. Complete the statement. The graph of f of x equals x squared has an axis of symmetry. This is the y-axis, which is also the line of x equals 0. Okay, remember the axis of symmetry. It's just this imaginary line. It goes right down through the vertex. It cuts the parabola in half. And it has two mirror images. So that's why it goes right along x. This is x is 0, so it goes x is 0, and it's right on the y-axis. All right, complete the statements about the graph of f of x equals x squared. The x-intercept of the graph is, and the y-intercept. All right, so the graph, or the x and y-intercept, it intersects at 0, 0. So the x and the y-intercept are both at 0. All right, which statement correctly describes the graph of f of x? Select all that apply. The graph is increasing for all values less than 0. The graph is decreasing for all values less than 0. The graph is increasing for all values greater than 0. And the graph is decreasing for all values greater than 0. All right, so if you look at the values that are less than 0, okay, these are the values that are less than 0, and you can see that these values are decreasing. And then once you get to 0, you can see they start increasing again. And you also can see that from the table. Okay, 16, 9, 4, 1, 0. These values are decreasing. And then once you get to 0, you start increasing again. So the graph is decreasing on all x values less than 0 and increasing on x values greater than 0. For all x values other than x equals 0, the function of f of x equals x squared has a positive value. Explain why the value of the function cannot be negative. All right, so it can't be negative because what we're doing is taking a number and we're squaring it. And it doesn't matter if you have a positive number or a negative number. Remember, when you square a number, you're going to get a positive number. So if I square 2, I get 4. If I square negative 2, I also get 4. So that's why none of the values other than 0 can be negative. Anytime you square a number, it's positive, and the only thing in this function is something squared because it is the parent function. Which statements correctly describe the function and its graph? Select all that apply. All right, the domain and range are all real numbers. The domain is all real numbers, and the range is all non-negative real numbers. All right, remember the domain and range are your x and y values. The domain is your x, so what it does going to the left and what it does going to the right. If you look, it has an arrow going to the left. It's going up, but to the left continuously and to the right continuously. So the domain is all real numbers. But the range is your y values. And you can see that the graph is going to include everything above 0, but nothing below 0. So there's no part of the graph that ends up being below 0. So this one, the domain is all real numbers and the range is all non-negative real numbers, is true. As x approaches negative infinity, the graph approaches negative infinity. As x approaches negative infinity, the graph approaches positive infinity. All right, so this one's going to be correct because, remember, it's a U-shaped graph, and this is talking about the end behavior. So as x approaches negative infinity, so as x goes to the left, what is the graph doing? It's going up. So it approaches positive infinity, okay? As x approaches positive infinity, all right, so that means as the graph goes in this direction, this is your x positive side, and this is your x negative side. So as the x goes on the positive side, as x approaches positive infinity, the graph approaches positive infinity. Again, it increases with an arrow, which means it increases without bound. So that one is true as well. And it's just about reading the question and understand what it's asking. And that's the end behavior is just talking about what does this side of the graph do as it goes to the left, and what does this side of the graph do as it goes to the right. All right. For which interval does the function f of x increase the fastest? All right. So the slope from 0, 0 to 2, 4. All right, to find the slope, remember we take y minus y divided by x minus x. So we're going to do 4 minus 0 over 2 minus 0. 4 divided by 2 is 2. The next one is 16 minus 4 over 4 minus 2. 16 minus 4 is 12 over 2, or 6. And the slope of the last one is going to be 36 minus 16 over 6 minus 4. Remember, this is average rate of change. That's what we're looking at, which is your slope. So this is going to be 20 over 2, or 10. All right, so the slope between each one of these can be found easily. And then it says, for which interval does the function increase the fastest? All right, so your x's, this is talking about your domain. So from the x's 4 to 6, it increases the fastest. Okay, so this says so the function is increasing. It's actually increasing the whole time. From 0 to 36, if you go back up, you'll see that it is increasing this whole time on this side of the graph. But the question asks us which interval increases the fastest. All right, that's all for task 1. If you have any questions, let me know.